Okay, hi everyone. This is going to be task 5, question 4 from the Chemistry's Kinetics booklet. This one is more tricky because there are 3 substances that could appear in the rate equation, and also the values that you're given for the rate are in standard form, which makes the relationship between them seem a little bit more obscure. So if you do want to, you can write the numbers out as I've done here, and I think visually that makes it a lot easier to see the relationship between them. So you can see that this is double this and this is double this, etc. Okay, right, let's get to calculating the orders of reaction. Okay, so let's start with the concentration of hydrogen ions, and you can see that going from 0.5 to 1.0, whilst all of the other concentrations remain the same, the concentration of hydrogen ions increases by a factor of 2. And what happens to the rate? Well, if you do 0.0018 divided by 0.009, there's a factor of 2. So as the concentration of hydrogen ions is increased by a factor of 2, so the rate is increased by a factor of 2. And that means that the order with respect to hydrogen ions is first order. Let's move on to the concentration of propanone here. So the thing that you notice when you start looking at the concentration of propanone is that it doesn't increase by an even number or an even factor, and that makes it a little bit more tricky. So what factor has it increased by? Well, 8 divided by 6 is 1.3 recurring, so it's increased by a factor of 1.3 recurring. Now then, let's look at the way that that's increased. So let's see, comparing experiments 3 and 4, we can see that the concentration of iodine stayed the same, concentration of hydrogen ions has stayed the same, and the concentration of propanone has increased by a factor of 1.3. So let's look at the rate and see how that's changed. Well, let's do this one in standard form. 2.4 times 10 to the minus 4 divided by 1.8 times 10 to the minus 4. That's 1.3 recurring. So that's increased by a factor of 1.3 recurring as the concentration is increased by a factor of 1.3. So we can conclude from that that the concentration, the order with respect to the propanone is also first order. Now the concentration of iodine and the order with respect to iodine. This is a bit more tricky because it involves taking into account the effect of either the hydrogen ions or the propanone. It doesn't really matter which one you choose, but whichever set of experiments you compare, you're going to have to take into account the effects of the hydrogen ions or the propanone. Okay, so I'm going to choose these 2 experiments, so sort of 2 and 4 there. So let's see what's happening between those 2. Well, the concentration of hydrogen ions has dropped by a factor of 2. The concentration of the propanone has stayed the same, and you can see that the concentration of the iodine has been multiplied by 2. And we can see the rates here. Okay, so let's see. First of all then, the concentration of hydrogen ions has decreased by a factor of 2. We know that hydrogen ions are first order, so the rate, 2.4 times 10 to the minus 4, oops, losing it there, 2.4 times 10 to the minus 4 divided by 2 is equal to 1.2 times 10 to the minus 4. So that's what the rate should be based on the effect of the hydrogen ion concentration. We can see that the concentration of propanone is actually the same, so that won't affect the rate. So that means that the concentration of iodine doubling from 0.02 to 0.4 will have the effect on the rate. So let's see what the effect on that rate is. Well, we know it should be 1.2 times 10 to the minus 4 for the effect of the hydrogen ions. And actually we can see that it's still 1.2 times 10 to the minus 4 when the concentration of iodine has increased. So actually increasing the concentration of iodine has had no effect on the rate. So from that we can conclude that iodine is zero order. Then we can write our rate equation. So rate is equal to K, the rate constant, multiplied by the concentration of hydrogen ions, first order, concentration of propanone, and because the concentration of iodine is zero order, that doesn't appear in the rate equation. Let's rearrange that to find a value for K. K is equal to the rate divided by concentration of hydrogen ions multiplied by the concentration of propanone. I'm going to choose, I'll choose the bottom one again, so K is equal to the rate, which is 2.4 times 10 to the minus 4 divided by the concentration of hydrogen ions, 1, multiplied by the concentration of propanone, 8, and work that out, and that gives a value of 0.3 times 10 to the minus 4, and the units moles decimeter cubed per second.